In my last couple of jobs, I have kind of by accident become the certificate guy. I'm no expert in certificates, but I have learned as much as I need to know to work with them. In this video, I'll go through an example of how to create a TLS certificate with a level 1 root certificate. We're going to deploy that and see a deployed site make use of it. I'll also lightly touch on the certificate store snap-ins in Windows and show how they can be used. I'm not going to go into how HTTPS works in this video. That will be beyond the scope of it and could be a topic for another video. So let's take a look at our scenario. We've been asked to set up a test server which we're going to deploy our application to and test. And so we're going to navigate to that. I've got another computer on my network called Jekyll's and I load it up and I see this. What's going on here? Your connection is not private and there's something about the certificate not being secure. This is not something my tester is going to want to deal with, and in addition to that, it could cause problems with the actual functionality. So let's proceed, and if we go through, our application will load, and let's go and take a look at this certificate a little bit more. So I'll click on the not secure link and bring up our certificate and let's examine it. So we can see it's issued to localhost. My server's Jekyll's. That is a problem. It's valid in terms of expiry date, so no problem there. And we're going to go down to subject alternative name, not the same as Jekyll's again. And there's a little cross here in the certification path, which is telling us that the certification chain is not valid. So there's a couple of things we need to do to avoid incurring the wrath of the browser. Let's take a look at this certificate and we'll go through them. If we go back to the general tab, issued to, that needs to be the same as the name of our server. The date range needs to be valid. And the way I understand it, the way it works is it goes down to the subject alternative name and checks the DNS name. And that has to be the same as the name of your server. Otherwise, it falls back to the subject where the common name is. And if the subject alternative name doesn't have it, then that has to. And of course, we need to have a valid certification chain on this certification path. Before I get into how I go about solving all of these problems, let's go and look at a site to see what it looks like when a certificate is working properly. I'm now going to navigate to a well-known website. The first thing to note is that we've got this padlock here. It's not red in color, so there's no visual cue that there's a problem. We'll now click on that button to take a look at the certificate, and you can see that the issued to address is correct. It's the same as the server. The date range is valid, and if we go and look at the subject alternative name, you can see the DNS name is the same as the URL. So we can now just go to the certification path, and we see here we've got this chain of certification where the amazon.com.au certificate has this intermediate certificate and then a root certificate. And so I'm not going to go into exactly how all that works. The reason for it is to guard against man-in-the-middle attacks, but that is another video in and of itself. So let's take a look at the intermediate certificate, examine that a little bit. If we go to the certification path, obviously we can see that it's got the root certificate. And what we want to do now is use a tool in Windows which enables us to take a look at the certification stores and find our certificates and have an understanding of where they are and why they're there. And so if we go to the root of this, we can have this find certificates dialog, and we'll go back to our certificate and grab the thumbprint. Thumbprint is a hash, and so we paste that in there. Select SHA-1 hash from the drop-down box, and I'm going to look in all certification stores. I can filter that, but let's take a look at the whole thing. And we can see here it's found it, and scrolling across, we can see it's in the Intermediate Certification Authority store. And that kind of makes sense because it's an intermediate certificate. It's the one between the root and the leaf certificate, if you will. And so we'll now take a look at the root certificate and basically do the same thing there. We're going to find that in the certification store. So let's go to the thumbprint and we'll grab that and open that dialog again, copy and paste paste rather, and we can see we've found it. It's in 2 stores, but the one we're interested in is that top one, the Trusted Root Certification Authority store. Now, the reason that's in there is because that is the root certificate, and that's the one that is at the head of the chain of certification, which is validated. Now, if we go to that store, we can see we've got all of these certificates. Now, I'm not 100% sure how these actually get on there, and you can see I've highlighted the root fiddler certificate, but that again is another conversation. But I suspect these get installed with Windows and with Windows updates. These are very big companies, security companies that have partnerships with the operating systems, etc. They may get installed with the browsers. I'm not 100% sure, but it's beyond the scope of this video. The reason we need to know that is because for the one that we're going to create to solve our problem, we need to manually install this on all of the computers of the testers. And that's not exactly a huge task, because I don't know about you, but I've only ever worked with teams where there's 1 or 2 testers, but that's what we need to do. So let's get down to solving our problem. I'm going to open Visual Studio, and I've got a little WinForm application which I've got here. The GitHub details will be in the details of this video below. And we'll go over to the Nougat packages, and the one that does the heavy lifting here is this one at the top, Certificate Manager. This is a really good package. It enables you to do all sorts of things in terms of creating certificates and chaining them, etc., multi-levels, whatever you need. What I've got here is limited in scope. It's just a front end which basically enables you to create a trusted certificate. And this tab we're looking at here, the TLS Cert tab, has 2 group boxes, the TLS on the right and the root certificate on the left there. And you can see with the TLS one, all of those fields are disabled. That's because we're going to create the root certificate first. And there's also this tab here which is used for self-signed certificates, and I use that for identity servers. In any case, let's get going. We don't need to have the DNS name or common name being the same as the server, because this is the root certificate. So this is the certificate authority. So I'm just going to create a name there, and I'm adding a friendly name here, which I'll show you how that makes it a bit easier to identify certificates in the certificate store. Then we can just chuck in a password here, and I've got a little I symbol here which enables the visibility of that. And we have made that 10 years valid. I've just got to clean up a bit of validation here, got to remove some spaces, and we should be good to go. And so we'll put that just on a folder on our hard drive, and I'll just give it a name that makes sense to me. It's not terribly important. And then you can see that's all disabled now, and we go over to the TLS side. And this time the DNS and or common name has to be the same as the server, so I'll just make them both the same. And I'm going to add a friendly name here again, which just makes it easier to identify the certificate in the certificate store. And then we can add a password, which is just, doesn't matter, it can be anything, just so long as you remember it. And we'll drop that again somewhere on our hard drive. And these are PFX files, so they contain the private key as well as the public key. And that's all we need the application for at this stage. So the first thing that we need to do now, now that we've got our certificates, is to take the TLS certificate and install it on the IIS server and bind it to that site that we are using. So this certificate here is the one I'm talking about, and that is the certificate that gets downloaded when an HTTP request is sent to that site, and then the normal handshake occurs, and part of that whole process is the validation of the certificate chain, which is why we need the certificate root. So we've now remoted in, and if we go and look at the site I set up and check out the bindings, The HTTPS binding has this certificate here, which is, just some weird development certificate, localhost, useless, no good to us. So we want to install, as I said, the certificate that we've just created, the TLS certificate that we've just created. So I put this on the hard drive of this machine, and I'm just gonna find it now. There it is, and password, because the PFX includes the private key, and I'm going to chuck it in the web hosting store, and so that's now done. Now let's bind it to the website, and so just open up that binding again, and there we go, selected. So we're getting a little message there which is saying that there's no trusted certificate here, and basically that's the thing that we need to install next. Now technically we don't have to install that on the server, but it's pretty handy to install it on the server, because that way you can actually load the site on a browser on the server if you want to check something out. And remember, this is a test environment, so it's fine to do that kind of thing, I would think. So what I'm doing now is opening up the certificate manager. This snap-in shows the certificate stores for the local machine, and we're going to install that, import that root certificate that we created into the root certification authority store. And so we just select that, and we'll be prompted for a password. And that's the particular store we want it in, and finished. And so it's as easy as that. But as I said, you don't really need to do that on the server. It does enable you to view things in the browser. But anyway, we're just going to quickly pop in and see what we've just installed. And you see here the friendly name, that's the friendly name that we gave it, which just makes it easy to identify by eye in the store. So I'm going to go back to my current machine, and this root certificate we need to install on this local machine to complete the chain. And so we put the password in here. And this is what I was talking about before in terms of manually installing it into that trusted root certification authorities store. Those other ones are automatically there, but we've got to manually install that for our testers. And so when we now load that website, we're going to have to actually close the browser and open it again. And I'll actually might even restart the website in IIS just to make sure that it's picking up the binding. And now when I load this again, we should have no certificate issues. And there we go. We see we've got the black padlock, which indicates we've got a secure HTTPS connection. The issued to is the same as the server name. It's valid in terms of date. The DNS name is the same as our server, Jekyll's, as is the common name. And on the certification path tab, we've got that chain, which is a valid certificate chain. I hope this video has been helpful to you. By all means, clone the code of that application that I wrote, which helps create the certificate, build it and use it, fork it, do whatever you like with it. And please subscribe to the channel and like the video. Thank you.